Welcome back to Maths with Mrs. J. We've been learning about differentiation and we've been learning a few rules that look pretty awful in rule form, but to actually use them is relatively simple. Today I want to teach you about the chain rule. Now the chain rule is highly useful. It's a little bit akin to solving equations in the sense that you're working your way back in. It's like if you have a function of a function of a function, you go from your outermost function and differentiate your way in. The rule says if y equals u of x, then dy dx is dy du du dx. I'll show you that setting out. You'll probably know by now that I don't go by that setting out all the time. I'll show you just one like that. So what we're saying is let u be x squared plus 3. So y is obviously u cubed. All right, this is your u. So du dx is 2x and dy du is 3u squared. Now, we need to put this back in terms of x. So u was this x squared plus 3 thing. All right. So dy dx is dy du by du dx, which is 2x, we'll do this one first, 3 times x squared plus 3 squared times 2x. And when we simplify that down, we get 6x outside of x squared plus 3 squared. Now, let me show you practically how I work with the chain rule. So we should say we've used the chain rule. It doesn't matter how many functions on functions you have. If you start with your outermost function and differentiate that as if it were just a plain x, and then differentiate the inner function and multiply, I'll show you. Let's do this one here. This is a relatively simple chain rule situation. So dy dx. We pretend for a minute that this was just x to the 7. So we get 7 that to the 6. All right? That's like our dy du part of the rule. But it wasn't just an x, was it? It was a function of x. So the chain rule says we need to multiply by the derivative of that inner function. So that's your chain rule coming in there. And then we can just tidy it up, obviously get all your numbers out the front. And there we go. Quite easy, particularly if your inner function is just a linear function, because then the derivative of that's just a constant. Let's have a look at this one. This one is a little bit more tricky. Before we even do anything, just thinking back a couple of videos ago, we need to write this in index notation before we can differentiate it. So this is really x squared plus 1 to the negative 1/2. Negative 1/2 because it's the square root in the denominator. Okay, now f dash x, let's go. So negative 1/2, this business. Now we're going to decrease that by 1, so we get negative 3 on 2. But this wasn't just an x, this was a function of x. So we now need to multiply by the derivative of that innermost function, which is our x squared plus 1. So that's our chain rule coming into effect. Okay, what are we going to do here? Well, the 2's will cancel. You're going to end up with negative x in the numerator, and in the denominator, you're going to get this x squared plus 1 to the 3 on 2. I'd be inclined to maybe do square root of x squared plus 1 cubed, just to sort of put it vaguely in the same sort of framework as it was in the question. So just to say that again, chain rule, you sort of pretend that you're just dealing with an x and do the normal thing. So 7 that to the 6, but then you've got to multiply by the derivative of your inner function. Now, often we'll be dealing with more than just one function of a function. We might have a function of a function of a function, and you just work your way in from the outside. We'll get plenty of practice, so don't you worry.